Okay, we have here another integral from the MIT Integration Bee 2024 lightning round number 1. We've got the integral from 0 to 1, 1 minus x 3/2 all to the 3/2 minus 1 minus x to the 2/3 all to the 2/3 dx. This is a problem I did a few months back. I did two methods on it. We did beta function and we also did something kind of graphical. In this video, we'll do a third method, kind of like the graph method, except without the graph. We'll just do it all through calculation. For the first step on it, what I want to do is let's just take this and break it up into two integrals. And then for step 2, this is kind of unusual. What I want to do is let's take this minus sign and use it to flip the bounds. The reason I say unusual is we almost always flip it to get it where we're going from 0 to 1. We usually want the higher bound on top, but we're gonna write this from 1 to 0 and make this a plus. And then here, what I want to do is use what we found in that first video, which, I mean, of course you might not have seen that video, but it's just that this thing is going to be the inverse of this thing, or vice versa. So what I'll do is, just to show it, let's call this thing y. And then if I just solve for x, that should give us our inverse function. So first, let's take the 2/3 power on both sides. So that way this is going to just cancel with this. Then I can kind of just reverse this, add this x to the 3/2 on one side, subtract, and what we get is x 3/2 is going to be 1 minus y to the 2/3. And then all I need to do is let's take the 2/3 power on both sides, take the 2/3 power here, but that cancels, and we just get, let me get rid of all this, and this thing's just our x. For the inverse, we switch our variables. We'll change this to a y, we'll change this to an x, and we get 1 minus x to the 2/3, but this thing, that's exactly this. So what I can do is, let's just get rid of all this junk, and I'm gonna put some labels on things. I can call this thing f of x, I can call this thing f inverse of x. We'll have our bounds. This will be our a, this will be our b. We can find f of b by plugging 1 in here, but that's going to be 0. So I can say this upper bound is f of b. And then for our f of a value, just plugging in 0 here, well, we're going to get 1 to the 3/2, that's just 1. So I can call this thing f of a. And so what we've just shown is this is in the exact right form to use a formula for integrals with inverse functions. So we have our formula down here at the bottom, and I derived this in a recent video, so I'll provide a link in the description if you want to see where this comes from. But since we've determined we're in the exact right form with all the right bounds, the inverses, we can go right to our formula. We know our a, b, f a, f b. So what we want for our solution is going to be this stuff over here. Just plug in b times f of b, 1 times 0, minus a times f of a, 0 times 1. We get 0 minus 0. And so our solution to this is just 0. Now, of course, I don't know if you saw that other video where we did the graphical approach. And of course, you look at a graph, that's going to be an easy way, a quick way to see that it's 0. The other thing you can kind of use, so I mean, I did this out like not knowing what b and f of b is, but if you quickly recognize the zeros, you can kind of see how this is going to zero out each term. Of course, there's a lot of different ways this could end up being 0. It doesn't have to be 0 to 1, but this is actually like kind of the most common case where you can kind of recognize it quick. Once you see the zeros, you know this is going to work out to 0. Okay, that's it for today. Thanks everyone for watching. Have a good day.